What kind of weapon is a missile? First, a missile uses its own engine to fly over long distances. There are two types of engines: jet engines and rocket engines. A missile's propulsion system can be a jet engine that uses liquid fuel, or a rocket engine that uses solid fuel. A jet engine compresses air and injects fuel to burn it, which generates thrust. A rocket engine, on the other hand, burns an internal propellant to create thrust. A missile also contains a guidance system, which is used to guide it toward its target. The guidance system controls the missile by calculating information obtained from various sensors. These sensors can include GPS receivers, infrared detectors, or radar. In addition, a missile also contains a warhead capable of destroying the target. The difference between a missile and a rocket is that a missile is equipped with a warhead. This warhead is triggered by a fuse. In modern warfare, the first missiles used in combat were the V-1 and V-2 missiles. The V-2 missile was developed by Germany during World War II. The V-1 missile used a simplified jet engine called a pulse-jet engine. Now, let's take a brief look at the structure of a pulse-jet engine. First, air and fuel enter the combustion chamber through the intake. A spark plug is used to ignite the mixture. When the pressure in the combustion chamber rises due to the explosion, the valve closes. The exhaust gases are then expelled, generating thrust. After the exhaust gases are expelled, the pressure inside the combustion chamber drops, and the valve opens again, allowing air and fuel to enter. Another explosion occurs. This process repeats rapidly, and the resulting exhaust gases propel the missile forward. A pulse jet engine means that, just like a heartbeat, it produces a stream of jet blasts. It measures distance by the number of rotations of the propeller at the front. When the preset distance is reached, the fuel supply is cut off, and the missile falls. It maintains its direction using a gyroscope located behind the propeller. Inside the gyroscope, there is a rapidly spinning gyro. A gyro that isn't spinning will quickly fall over. But if the gyro is spinning fast, it won't fall over. What happens if you tilt the floor while the gyro is spinning? Will the gyro tilt just like the floor? No, it won't. A rapidly spinning gyro like this maintains its rotational state due to inertia. This inertia is called the gyroscopic effect and can be used to measure angles and angular velocity. The rear of the missile houses TNT explosives and a fuel tank. There's a device that controls the fuel, and the engine is located above it. The missile also has main wings and a tail rudder. The V-1 missile can be considered the origin of the modern cruise missile. A cruise missile is a missile that flies like an airplane, with little change in altitude or speed. The term cruise has the same meaning as when we say, an airplane is cruising. Cruise missiles use jet engines, so their speed is relatively slow. However, they can fly at low altitudes to evade enemy radar. Over the sea, they can fly as low as about 5 meters. This low-altitude flight makes them very difficult to detect by radar. Furthermore, cruise missiles, like airplanes, can freely change direction. Next up is the V-2 missile. It was also developed by Germany during World War II. The V-2 missile uses a rocket engine to fly. Rocket engines are divided into liquid propellant rocket engines and solid propellant rocket engines. In a liquid propellant rocket engine, the fuel and oxygen used as propellant are in a liquid state. The propellant is pumped into a combustion chamber and ignited to generate thrust. By adjusting the amount of propellant entering the combustion chamber, you can control the speed. The V-2 missile was a liquid propellant rocket that used an alcohol solution and liquid oxygen. Liquid propellant rockets have many disadvantages. It's difficult to store fuel inside the missile for a long time. They are larger, more complex, and also more expensive than the structurally simpler solid propellant rockets. Therefore, liquid propellant rockets are often used for space exploration, while solid propellant rockets are mainly used for missiles. If stored properly, solid propellant rockets can be used for more than 10 years. Solid propellant rocket engines use a solid-state propellant. Ammonium perchlorate is used as an oxidizer to provide oxygen. The oxygen element it contains provides the oxygen. Aluminum powder is typically used as the fuel. Aluminum burns at high temperatures and is inexpensive, so it is widely used in solid propellant rockets. Since ammonium perchlorate and aluminum are in powder form, a binder is needed to mix them. A hollow space must be created in the center of the solid propellant. To achieve this, the liquid propellant mixture is poured into a mold to harden. The shape of this hollow space can be made in various ways. An igniter is used to light this space. The igniter contains a pyrotechnic charge that can be ignited by an electrical signal. The propellant then catches fire and burns from the inside out, generating thrust. The propellant is a type of explosive, so it's difficult to control the thrust once it's ignited. The cross-section of the propellant comes in various shapes. Depending on the shape, the missile's thrust will also change. This propellant burns in a specific way. As the cross-sectional area changes, the thrust also changes. The larger the cross-sectional area, the greater the thrust. The outer shell of the rocket is usually made of a lightweight and strong aluminum alloy. When the propellant burns, it generates high-temperature radiation. To protect the outer shell from the high temperatures, the propellant is wrapped in an insulating material. The V-2 missile can be considered the origin of ballistic missiles. What is a ballistic missile? After an artillery shell is fired, it flies along a parabolic trajectory. This path is called a ballistic trajectory. A ballistic missile is one that flies along this type of parabolic trajectory. A missile that flies in the initial phase of launch, it uses the power of its rocket engine to ascend. Once its fuel runs out, it continues to fly based on inertia and then falls under the influence of gravity. The V-2 missile flew using an inertial navigation system. This data is calculated by a computer in the guidance system, which determines the missile's flight distance. Because the inertial navigation system performs its calculations inside the missile, it is not affected by jamming signals. Therefore, modern missiles also use it as their basic navigation system. Today's inertial navigation systems are only about the size of a semiconductor. The warhead was loaded with TNT explosives. Ethanol and liquid oxygen were used as fuel, and a turbopump was used to draw in the propellant and ignite it. The V-2 missile ascended to the stratosphere, reaching an altitude of 80 kilometers above the ground, with a flight range of over 200 kilometers. After World War II ended, the Allied forces used Germany's missile data to develop their own missiles. A missile is a weapon equipped with a guidance function. Guidance refers to the function of directing the missile to its target. A missile is a weapon equipped with a guidance function. Guidance refers to the function that directs a missile to its target. The main types of guidance include autonomous navigation guidance, command guidance, and homing guidance. First, let's look at autonomous navigation guidance. There are two methods that can assist the inertial navigation system. One is using GPS satellite navigation guidance, and the other is terrain matching navigation. Satellite navigation guidance is a method that uses radio signals from satellites to determine its current position. Terrain matching navigation is a method that, during flight, scans the surrounding terrain. There are two types of this. One is TERCOM, or terrain contour matching, which flies by measuring the terrain's altitude. The other is DSMAC, or digital scene matching, area correlation, which flies by analyzing the shape of the terrain. The TERCOM method uses a radar altimeter to periodically measure the terrain's altitude. As the missile flies, it compares the measured values with data that was pre-stored in the missile for comparison. The SMEC, on the other hand, uses a digital camera mounted underneath the missile to take images of the ground and compares them with images that were pre-stored in the missile for comparison. With satellite navigation systems, there's a risk that the GPS signal could be jammed, and terrain matching methods are difficult to use in deserts or over the ocean. Furthermore, they can also be affected by weather or changes between day and night. Therefore, missiles primarily use an inertial navigation system to calculate their position and use either satellite navigation or terrain matching navigation as an auxiliary system to correct for errors. Next, let's look at command guidance. In command guidance, the missile doesn't decide how to fly on its own. Instead, it moves according to external commands. There's a radar that tracks the missile and a radar that tracks the target. A computer analyzes this information and sends commands to guide the missile. There's also another method, which is guiding the missile by aiming a radar or an optical sight directly at the target. A similar method is beam riding, which uses a laser beam to guide the missile. The advantage of command guidance is that it simplifies the missile's internal structure, but the disadvantage is that it's difficult to use when the target is far away or out of the line of sight. Finally, there's homing guidance. Homing guidance means the missile directly finds and tracks the target. Homing guidance uses various types of seekers. First, there are infrared seekers, which track a target's heat. Because of the heat generated by an aircraft's engine, it's very easy to detect planes using infrared. Early infrared seekers could only detect the shortwave infrared radiation produced by the engine's heat. Because of this, during tracking, they were easily fooled by released flares. But later, sensors were developed that could detect midwave infrared radiation, which also allowed them to detect the heat from the aircraft's body. There's also an imaging seeker, which uses a camera to directly capture the target's appearance. If the target's appearance has been pre-programmed into the missile, the imaging seeker can recognize its shape and attack the target. It's mainly used to attack fixed buildings and is affected by the weather, season, and time of day. There are also infrared cameras that can detect both heat and images at the same time. Infrared cameras have lower resolution and have difficulty distinguishing heat rising from the ground. This method, where the missile follows a signal emitted by the target, is known as passive homing guidance. When the missile actively emits a signal to track the target, it's called active homing guidance. Active guidance uses a radar seeker. The radar transmits radio waves and detects the target by receiving the reflected waves. Radio waves have a longer wavelength than infrared rays, and they travel more effectively. This allows them to detect targets from much farther away. However, since the radar has to be mounted inside the missile, its size is limited. As a result, its detection range is also shorter, at about 10 kilometers. Active guidance is typically used when the missile is closing in on its target. Then there's semi-active guidance, which is a middle ground between passive and active guidance. With this method, the missile itself doesn't transmit any radio waves. Instead, it receives radio waves transmitted by a friendly source and uses those to track the target. Missiles typically use a combination of guidance methods. Initially, they use inertial and satellite navigation systems. They receive command updates mid-flight ... to correct their course. Then, as it gets closer to the target, it uses its seeker to home in on it. The guidance system is the computer inside the missile. It processes data sent from various devices like the seeker, the inertial measurement unit, and the command receiver, and uses this data to control the missile. A missile's purpose is to destroy its target, so it needs to have a powerful explosive charge. The part of the missile responsible for the explosion is called the warhead. In the early 20th century, warheads primarily used TNT as their explosive. By the mid-20th century, high-performance explosives like RDX and HMX had been developed. Warheads can be categorized by their type of explosion. First, let's look at the blast fragmentation warhead. When this warhead explodes, its outer casing shatters into tiny pieces, creating shrapnel. This shrapnel spreads out at speeds faster than a bullet, which makes it extremely dangerous. The surface of the warhead is pre-scored with grooves, so that it breaks apart in a predetermined pattern. Sometimes, around the explosive charge, fragments are even pre-packed. Next up are directional warheads. This type of warhead directs its explosive force, concentrating it in a single direction by placing multiple detonators around the outside of the warhead and only setting off one side. The blast force can be focused in a specific direction. Another method is to change the shape of the warhead. First, an explosive is detonated to reshape the warhead, and then the main charge is detonated within this altered shape, concentrating the explosive force in one direction. Some warheads are pre-shaped in order to focus the blast force in a single direction. This is known as a shaped charge warhead. When the warhead detonates, the blast force converges toward the center. The front of the warhead has a metal liner. When the warhead explodes, it vaporizes into a fine gas under the intense pressure. This metallic gas is called a metal jet. The metal jet is much heavier than the explosive gases. When this heavy jet strikes at an extremely high velocity of about 6 kilometers per second, its penetrating power increases. It's used to penetrate thick tank, armor, or bunkers. It can punch through about 70 centimeters of steel plate. When the warhead hits a target, the fuse is triggered by the impact. An explosive is sandwiched between two armor plates, and it detonates when an impact occurs. This explosion counteracts the force of the shaped charge to penetrate reactive armor. Tandem warheads with two shaped charges were developed. The front warhead triggers the reactive armor first, while the main rear warhead penetrates the primary armor. A warhead is detonated by a fuse. Fuses can be categorized as impact fuses, delay fuses, and proximity fuses. A contact fuse activates on impact with the target. A delay fuse explodes about 0.5 seconds after hitting the target. It detonates inside the target, not on the outside. This causes much greater damage. Since missiles travel at incredibly high speeds, they can, in a very short time after impact, penetrate the target. An explosion in this state is what describes the function of a delay fuse. In order to penetrate bunkers buried deep underground, they use warheads made with a steel casing that weighs several hundred kilograms. A proximity fuse detonates near the target. For a fighter jet, because of its extreme speed, scoring a direct hit is very difficult. So if a direct hit is unlikely, the missile will explode near the target to inflict damage. Missiles can also be classified based on their launch point and target type. Surface-to-air missiles are launched from the ground at targets in the air. Air-to-air missiles are launched from the air at another airborne target. These missiles are typically fired during dogfights between fighter jets. That's all for this episode. We'll see you in the next one.